All right, let's talk about searching a binary search tree. So let's say we have a tree, like this one, and we'll call the tree T, and let's say we want to search for the key K. So in this case, the key could be 1, 2, 3, 4, 5, or sorry, 1, 3, 8, 4, 6, 7, 13, 14, 10, or it could also be something that's not in the tree. There's no guarantee you'll find it. What is a good algorithm for searching for a binary search for a specific key in a binary search tree? Well, you know you start at the root, and if the key value I'm looking for is less than 8, then I'll look to the left. If it's greater than 8, I'll look to the right. And I just keep doing that recursively. So I compare my key K to 8, and if it's less than, I compare it to 3. If it's greater than, I compare it to 6. And whenever it's equal, I just return that node, or the data associated with that node, or I keep searching. So I'll start at the root, and I'll recursively traverse the left if the key is less than the current key, and traverse right if it's greater than the current key. So at the very end, I'll either return the node that I found. So if the key was 4, I would have found it. Or if I didn't find the 4, I would return null. Or let's say I was searching for the key 2. I would go from 8 to 3, 3 to 1, 1. Well, there's nothing there, so I would return null. I didn't find the key value. All right, so how about inserting into a binary search tree? This is going to be a very similar process. So an insert, you're going to start at the root and you're going to do a search. So let's say I want to insert the node 2. I'm going to do a search for that particular key, and I hopefully won't find it. Otherwise, I have to figure out what I'm going to do with duplicates. And then I just create a new node and set up the pointer. So let's say I want to insert the key 2. I go from 8 to 3, 3 to 1, and I know that there's a null now here, so I can just create the new node with 2 and attach that right pointer to the 2. Okay, so here's my question. Given a binary search tree that's not necessarily balanced or unbalanced, so by that I mean we don't know that it's perfectly balanced, and we also don't know that it's the worst, most awful version of a tree. What is the maximum number of hops needed to search the tree or to insert a new node? And I'll give you these options. Constant time, so 1 hop, log of n hops, it depends on the height of the tree, or n. Okay, so I realize this is kind of a strangely worded question, because the maximum number would be sort of n if it was an unbalanced tree. But the tree might not necessarily be unbalanced. And we know in the best case, if it's a balanced tree, it's the maximum number of hops is log n. But what we're going to find is that, in general, it's really the height of the tree that matters. So if we can get the height of the tree to be closer to log n than it is to n, that would be good. But it's really the height of the tree, not necessarily this log n or n bound.